So let's look at questions 5 and 6 now. In questions 5 and 6, we are looking at what would happen if we added a strong acid or a strong base to one of the solutions for which we have already determined the pH. So question 5 asks us to look at what would the pH of the solution in problem 3 be if 15 grams of hydrochloric acid were added to a 1 liter solution? So here's the work I did for question 3. Up here, you can see my original concentrations. Well, the first thing I'm going to have to do is turn that 15 grams of hydrochloric acid into moles, because we can't just use grams directly. So hydrogen plus chlorine is 36.46 grams. So if I convert this to moles, 15 divided by 36.46, I figure out that I have 0.411 moles of hydrochloric acid. That's actually a fair amount. So remember the rule, acids add to acids and subtract from bases. You always add to the like and subtract from the unlike. So when we're looking at this formula up here, remember the acid is always in the base. So what we're going to do is really just tweak this to account for the fact that we have added acid, and we'll get new molarities within that ratio. So literally, what we will get here is our pH, our pKa will be the same still, right? 4.74. But now inside of this, I'm going to have to add my acid to my acid. So 0.416 plus 0.411. And on top, I'm going to subtract it from that base. So 0.609 minus 0.411. Put my zeros there. So that when I simplify this, pH is going to be 4.74 plus the log, let's see, 0.609 minus 0.411. So now I will have 0.198 on top and 0.827 on bottom. So that when I put those together, 0.198 divided by 0.827, what I get inside of this is 0.239. And when I take the log of that, I get negative 0.621. So this will be 4.74 plus negative 0.621, which will give me a new pH. So of 4.12. Pretty straightforward. All we did was convert our grams of hydrochloric acid to moles, and then adjust what was in that ratio based on acids adding to acids and subtracting from bases. So let's look at what would happen for question 6. Question 6 is asking us to look back at question 4 and say, what would be the pH of that solution if 0.050 moles of NaOH were added per liter? So let's go back to that problem solving. So our original pH is 10.42, but our problem tells us that we are adding 0.050 molar NaOH per liter. So basically, we can just treat that as that molarity. So this time we have a base. So just like acids add to acids, bases add to bases and subtract from acids. So this time when we modify our ratio, Our pH is still going to be, the pKa will still be the same. But now we simply need to modify what was in this ratio. So which one am I going to add this to? It's a base, so I'm going to add it to the base. The base is always that anion on top. So this will be 0.155 plus 0.05 molar NaOH. And on the bottom, I will take my acid and subtract that base. Remember that bases and acids react to neutralize each other. That's why it's taking away from the acid, but adding to the base. So when we simplify this, we get 10.64 plus the log of 0.205 divided by 0.205. And of course, the log of 1 is 0. So our pH is just 10.64. Sorry, it got all scrunched there. So there are problems 5 and 6. Hopefully that was pretty straightforward and it helped you with the problem solving.